Hello and welcome to Eternity Tutorials. Today I'll be taking up fundamental theorem of arithmetic. What does the fundamental theorem of arithmetic states? That every composite number can be expressed as a product of primes, and this factorization is unique apart from the order in which the prime factors occur. What does this mean? That we have a composite number. What is a composite number? A composite number is a number which has the factors apart from 1 and the number itself. For example, 6, 8, 9, these are all the composite numbers. Now these composite numbers, they have some prime factorization. Prime factorization as in these can be expressed as the product of prime numbers. Like 6 can be expressed as 2 into 3, 8 can be expressed as 2 into 2 into 2, and 9 can be expressed as 3 into 3. So each composite number can be expressed as the product of primes. Whenever they are expressed as the product of primes, for each number this factorization is unique. As you can see, for 6 it is 2 into 3, and this cannot be repeated in any other number. There is no such number which can have the same factorization as 6. Apart from this, the only difference can be that instead of writing 2 into 3, I can write it 3 into 2. But as we all know that the multiplication is commutative, so it is valid. The prime factorization is unique, but order of the prime factors can differ. Let me just take an example that I have to express 140 as the product of its prime. So we know that 140, the prime factors of 140 is 2 into 2 into 5 into 7. I can write it in the form of the exponents, which is 2 square into 5 into 7. Let me take another example. I take 156 and I express it in as the product of primes. The factorization of 156 is 2 into 2 into 3 into 13. As we all are aware of the exponents, so we write this also in terms of exponents, 2 square into 3 into 13. So this, according to the fundamental theorem of arithmetic, is the prime factorization of the two numbers. We can use the fundamental theorem of arithmetic for finding out the HCF and LCM. Let us see how. I have a question. Find HCF of 96 and 404 by prime factorization method. Hence, find their LCM. Now, how do we use the prime factorization? Let us write down the prime factorization of 96. Prime factorization of 96 is 2 to the power of 5 into 3. And the prime factorization of 404 is 2 square into 101. For all those who are not aware, we find the prime factorization of 96 as Again I take 2, I get 24. I again take 2, I get 12. I take 2 again, that 12 is divided by 2, and now 6 is divided by 2, I get 3. As you can see, there are 5 2's into 1, 3. Similarly, I take out the prime factorization of 404. I divide it by 2, I get 202. I again divide it by 2 and I get 101, which is 2 square into 101, and this is how I got the prime factorization. Now I write down HCF. Now two ways of understanding the HCF. Number one, either we take whatever is common out of these two factorization, or I take one number which is common in both, like I have 2 common in both, and which is the least power of 2 in out of these two. As we can see, out of 5 and 2, the least power is 2. So 2 to the power of 2, which is 4, is the HCF. Now we take LCM. As for the LCM, we write down all the numbers which are involved in the prime factorization of the two numbers, like 2, 3 and 101. I take the highest power of all the three factors. Highest power of 2 is 5, highest power of 3 is 1, and of 101 is also 1. So as you multiply them, you will get the LCM to be 9696. Now this is how we find the LCM of the two numbers. Now let us see how to find out the HCF and LCM of three numbers involved. So we have the question, find the HCF of 6, 72 and 120 by prime factorization method. Hence find their LCM. Now first step is to find the prime factors of the numbers given. We know the prime factors of 6 is 2 into 3. Now prime factors of 72 is 2 cube into 3 square. We find the prime factors of 120, which is 2 cube into 3 into 5. Now we find out the HCF. As I told you, the factors which are common. Now because we are finding the HCF of three numbers, so we take the factors which are common in 3, which is 2 and 3. These are the two numbers which are common in all the three numbers. The least power of 2 is 1 and the least power of 3 is 1. As you multiply, you get 6. Now for the LCM, I write down all the factors involved, that is 2, 3 and 5. As you can see, out of this, the highest power of 2 is 3 and the highest power of 3 here is 2, and 5 we have 1. So when you multiply, you get the LCM as 360. Now let us go for the next concept. We are aware that HCF of two numbers A into B into LCM of A and B is equal to A into B. That is, for the two numbers, the product of two numbers is equal to the product of their HCF and the product of their LCM. Let us take a question based on it. Now the HCF of 306 and 657 is given to be 9. We need to find LCM of the numbers 306 and 657. The result is mentioned above. I use the HCF into LCM is equal to A into B. HCF is 9. LCM we don't know, so I write it as it is. A, the numbers are 306 into 657. So we find the LCM as 306 into 657 divided by 9. So when you calculate it, your answer will be 22,338. So this is the concept of HCF LCM by using the fundamental theorem of arithmetic. If you have any doubts related to this concept, please leave a question in the comment section. I will make a new video with the answer to that question for you. Thank you.